Good evening, guys. So, yesterday we have discussed some of the number system problems. Yesterday we have discussed some of the number system problems. So, you have any doubt in that? Please let me know in the chat box. Please let me know in the chat window if you have any doubt. First of all, can you able to hear me? Can you able to hear me properly? Can you able to hear my voice properly? Is it clear or not? Please respond in the chat window. Guys, my voice is clear or not? Guys, please update. Please use the chat window whether my voice is clear to all or not. We can start the session. Guys, can you able to hear me? Please update. Can you able to hear me or not? Am I audible for you or not? So, you have any doubt in the previous session? We have uh, we have seen like basic problems in the number system, like to find out whether a given number is even or odd, or and also to find out whether a given number is prime number or not. You have any doubt in that? Shall we continue? So from today onwards, we'll be starting from the very basics of the number system. Okay, it is very important. Before moving on to the complex problems, we should know the basics very well. So can you able to see this eclipse window? Can you able to see this eclipse window or not? Please update. Fine. So before moving on, see, I'm requesting you all, please grab a pencil and paper and try to write down the logic. Try to think on your own about the problem and write down the logic. It is very important. If you're not practicing, you won't get the clarity. If you're not practicing, you won't get the clarity. So now, please observe this program. Class A, public static void main. We have main method. And now I have one statement. System.out.println 1, 2, 3, division operator 10. What is the result? What is the result we get for this statement? What is the result do we get for this statement? What is the significance of this division operator? Division operator. Whether it returns as the remainder or quotient. Whether it returns as the remainder or quotient. Please reply. So in case of division operator, it is returning as the quotient, right? Quotient. Now, how it is? So, what is the result of this expression? What is the result of this expression? We need to understand how it is. What is the task of this division operator? Now, 123, 123 division operator 10. What is the result we get? We get 1, 2 as the output. We get 1, 2 as the output. Just right click and run as Java application. So we get the result as 1, 2. We get the result as 1, 2. That is the quotient. In case of division operator, we get the quotient. We need to understand how it is working. So come to the B class. Come to the B class. 1, 2, 3, 100. Okay, 1, 2, 3, 100. 1, 2, 3, division operator 100. 123 divided by 100. What is the result we get? Right click, run as Java application. Now we are getting only one digit, that is 1. Only 1 we are getting. So in the previous program we got 1, 2 as the output. In the previous program we got 1, 2 as the output. Okay, in the class B program we are getting the 1 as the output. Now what is going on here? So basically general idea about this division operator, general idea about this division operator, it is removing the rightmost first digit in case of divided by 10. Number is divided by 10. Division operator 10. So it is removing the rightmost single digit. Rightmost single digit. That is the general idea for this operator. That is the general idea for this operator. It is removing the rightmost digit. In this case, the rightmost digit, that is 3. 3 is removed and 1, 2 is returning. And come to the B class. 123 divided by 100. Okay, 123 divided by 100. Now, in this case, rightmost 2 digits will be removed. Rightmost 2 digits will be removed. In case of 10, it is removing only 1 digit. In case of 100, it is removing 2 digit. Rightmost 2 digit. Observe the point here. It is removing the rightmost digits. It is removing the rightmost digits. Now come to the C class. Come to the C class. Now observe, these are the multiples of 10. These are the multiples of 10. 10, 100, 1000, 10,000, like that. So these are the multiples of 10. So tens, hundreds, thousands, 10,000s, 100,000s, then million. So what is the operations performed? Yeah, the base value, the original value, it is 456,123. 456,123. We have 1, 2, 3, 4, 5, 6 digits. We have 6 digits. We have in the number. Now the same number only I'm using while dividing with the 10 multiples. While dividing with the 10 multiples, the same number I'm using now. For the first case, it is removing one digit in the first case, that is this SOP. 456,123 divided by 10. It is removing one digit by. It is removing one digit when I'm doing the division by 10. Now the value will be 45612. 3 will be gone. 3 will be gone. 45612. Then in case of, if I divide this number by 100, rightmost two digits will be gone. Remaining are 5461. Remaining are 5461. In case of 1000, if I divide this number by 1000, three digits will be gone. Three digits will be gone. The remaining digits are 456, 456. Okay. If I divide this number by using 10,000, these four digits will be gone. These four digits will be gone. And the value will be 45 only. And the value will be only 45. These elements are removed. These elements are removed. And what about 100,000 case? 100,000 case. So rightmost, these digits are removed. 5 digits are removed. 5 digits are removed. 4 is the remaining value. 4 is the remaining value. In case of 100,000. In case of a million. In case of a million. If I divide this digit by million. So what would be the value? All these digits will be removed. All these digits will be removed. And 0. Okay. 0 is the value that we get. 0 is the value we get. All the digits will be removed and 0 is the value we get. Try to run this, run as Java application. Can you able to understand the sequence? What is the operations? What is the operation that is performed by the division operator? It is removing the digit. It is the removing the, it is removing rightmost digit. It is removing the rightmost digit. Now come to the next program. here what I'm doing, that int num is equal to 65789. I'm declaring one variable. I'm declaring one variable that is called num. I'm declaring one variable that is called num. I'm supplying the number that is 65789, 65789. Num will be having this value 65789. Basically, I'm trying to print the value as it is. I'm trying to print the value as it is, num. So here we get 65789, 65789. That is the base value. That is the original value. Now, what is the value we get here? Instead of directly supplying the number, I'm just storing it in a variable and then I'm performing the operation. Num division operator 10. Num divided by 10. Now, we know very well that it is removing the rightmost digit. If I divide it by 10, it is removing the rightmost one digit. Rightmost one digit. So, what is the value? 6578. 9 will be removed. 9 will be gone. 6578. Next. I'm dividing the number by 100. I'm dividing the number by 100. Now, the rightmost two digits will be removed. Rightmost two digits will be removed. See, original value. I'm performing the operation on original value. Okay, not this value. I'm performing the operation on original value. Now, rightmost two digits will be removed. That is 6578. Sorry, 65789 will be removed. 89 will be removed. Now, dividing number by 1000. So, it is removing the rightmost three values. These three values are gone. Now, the remaining value is 65. Of 10,000. If I'm dividing a number by 10,000, so how many digits are removed? Four digits are removed in case of 10,000. If I'm dividing a number by 10,000, four values are removed. The remaining value is 6. If I perform this on 100,000, 6 also will be removed. 0 will be returned. Now observe here, the base value itself it is returning. The base value itself is 65789. Try to run this program. Observe, base value are returned and then the operation divided by 10, divided by 100, divided by 1000 and 10,000. If I perform one more operation, it will be removed that also. Like if I'm adding one more zero here, 6 also gone and 0 will be returned. 0 is returned. So now we came to one understanding that it is removing, okay, the division operator, it is removing the rightmost digits. It is removing the rightmost digits in case of if I'm dividing with 10 multiples, okay, multiples of 10, multiples of 10. Now this is also simple. What I'm doing here, it is I'm declaring one variable num. I'm supplying the value. Then I'm declaring these five variables num2, num5. Okay, num1 to num5. Declaring five variables, and then I'm performing the operation. And I'm performing the operation. So the result will be stored with corresponding variables. Whatever the results are there on the right hand, that will be stored inside the left hand variables. Operations will be performed and the result will be stored in the corresponding variables. So what we are doing here, here num is not reinitializing. Okay, num is not reinitializing, and here every time actually I'm sending the original value. Okay, every time I'm sending the original value, we are getting the result. In this case we are performing the operation and we are storing it in a corresponding variable, but num is not reinitializing. Num is not reinitializing. Here I'm performing with the base or original number. I'm supplying the original number here, num divided by 10, num divided by 100. After this operation, the result will be stored back to this variable. Run this program, we are getting the result. So it is removing the rightmost digits. This is also simple. What we are trying to do here, it is num is reinitialized every time. 5 times num is reinitialized. 5 times num is reinitialized. Num is reinitialized 5 times. Every time it is removing rightmost one digit. Every time it is removing rightmost one digit. Why? Because we are dividing it with 10. Rightmost one digit will be removed. Rightmost one digit will be removed. 5 times I'm performing this operation and we have how many digits? We have 5 digits in this number. At the end we get 0. At the end we get 0. Num is reinitializing every time. Num is reinitializing every time. Right click, run as Java application. You can observe rightmost digit are removing. One digits are removed. Why? Because it is dividing with 10. It is dividing with 10. Okay, we came to one understanding that by division operator, by division operator, we can able to remove the rightmost digits. Fine. What about modulus operator? Mod or modulus operator. What is the significance of modulus operator? Come to this program, G. 123 mod 10. Mod or modulus. 123 mod 10. It is returning as the reminder, not the quotient. It is remi- uh, it is returning as the reminder. Right? It is returning as the reminder. See, in case of modulus operator, it is returning as the reminder, and in this case it is returning as the rightmost single digit. It is returning as the rightmost single digit. Modulus operator always gives us a reminder. Modulus operator or mod operator, it is always gives us the reminder, not the quotient. Now in this case 123 mod 10, it is returning as the rightmost single digit. Rightmost single digit, not removing. Not removing, please observe. Not removing like division operator. It is instead it is returning as the value. Rightmost single digit. Rightmost single digit. Now we get 3. Rightmost single digit is 3. Why? Because I'm dividing with 10. So it is giving us the value rightmost single digit, that is 3. It is not removing, it is returning as the value. Run as Java application. You can find out that 3 is returned. It is not removing, instead it is returning. 3 is returned. Come to the next program. Observe here. 10 multiples. Performing modulus operation. Operation on by using 10 multiples. By 10 multiples. In the first case, it is returning the first digit. What is the first digit? That is 3. It's returning 3. The second case, it is 100. Okay. Mod 100. Mod 100. It is returning 2 digits. It is returning rightmost 2 digits, not removing. It is returning rightmost 2 digits. So what is the rightmost 2 digits? 2 3 is returned. 123 mod 1000. It is returning as the rightmost 3 digits. Rightmost 3 digits. We get 123. Get 123. Now 123 mod 10,000. What is the value? Observe. If there are no digits are available to return, it will be giving us the digit that are available only. Okay. These many digits are available in the number, that is only returning. In case of mod operator, it is returning the value back to us. It is returning value back. It is not removing, it is returning. It is returning. It is the basic understanding of the mod operator. Now come to the next program. What we are trying to do here. So we are basically finding out the places, in the number system, places. So like units are ones, tens, hundreds, thousands, ten thousands, hundred thousands, millions. So that is the number place. Now I'm trying to find out the what are the digits are in the in what places they are. So whether the number is in units place or tens place, we can able to find out what is the logic for that. So I'm just trying to print from the beginning, from the unit place. I'm trying to print the values or numbers from the beginning. That is from the units place. Units are ones from the ones place. What is the logic here? Int num is equal to 47. Int num is equal to 47. Then int num1, another variable num1 is equal to num 47 mod 10. Now we know very well about mod operator. It is returning the value. It is returning the value, not removing. It is returning the rightmost single value, rightmost one value. If in case I'm performing the operation with 10, 47 divided by 10, it is returning 7. It is returning 7. Now num is reinitialized. Num is reinitialized. Num is equal to num division operator 10. Num is 47. Division operator 10. We know very well about the division operator that it is removing the rightmost digits. In this case, I'm dividing with the 10. So it is removing the rightmost single digit. Rightmost single digit. The remaining digit, that is 4. Remaining is what? 4. 4 is assigning to num. Num is reinitialized with 4. Num is reinitialized with 4. Then int num2 is equal to what is the current value of num? Current value of num, it is 4. 4 mod 10, it is returning as the rightmost single value, that is 4. 4. Now what is the num1 and num2? 7 and 4. 7 and 4. 7 and 4. 7 is in the ones place. 4 is in the tens place. 7 is in the ones place. 4 is in the tens place. See, this is the one ones place. This is the tens place. 7 and 4. 47. That is the base number. And what are all the number places? Ones and tens. Come to the next. So I'm trying to reverse a given two digit number and that is not ending with 0. I'm trying to reverse two digit number and that is not ending with 0. Okay. Only two digit number. I'm trying to perform. I'm trying to reverse the given number. I'm trying to reverse the given number that is only two digit. This logic works fine for only two digit and it is not ending with 0 and it is not ending with 0. If you are using 0, if the number is ending with 0, if you are using this logic, you might get other than expected result. Okay, it won't works fine for the more than two digit and it is ending with 0. Even if it is two digit also, if it is ending with 0, it won't work fine. So the condition is number should be two digit, number should be two digit and it should not end with and it should not end with 0. That is the condition. That is the problem we have and we need to find out the solution. Need to find out the solution. So what is the solution for this? As you can see here, please try to write down your own logic. Okay, that is very important. You need to try to write down your own logic. Okay, please don't um, you know try to copy from any of the resources. Just see the problem statement and don't see this logic. Try to build the logic for that problem statement. If you have any logics, okay, please send it. Guys, it is highly advisable. You need to get a pen and paper and you need to write down the logic, okay, and you need to trace out the program. That is very important. And if you do that, you'll get the clarity. You will get the clarity. Now, please observe here. The base value, the original value is 78. That is only I'm printing 78. 78 I'm printing. Then I'm declaring one variable called last digit. I want to get the last digit. Int. Int last digit is equal to num mod 10. Num mod 10. We know that it will be returning as the rightmost single digit, not removing. Returning. It is returning as the rightmost single digit. That is 7. Sorry. Here, what is the thing happening? So observe, is returning as the rightmost single digit, that is 8. Rightmost single digit, that is 8. Now last digit is reinitialized. Last digit is reinitialized. What is the last digit as of now? It is 8. Last digit is 8. So 8 into 10, it is 80. 8 into 10, that is 80. After that, num is reinitialized. Num is reinitialized. What is the num value as of now? What is the num value as of now? It is 78. 78 division operator 10. 78 division operator 10. Now it is removing the rightmost single digit. It is removing the rightmost single digit. Rightmost single digit, that is 8. It is removed. 7 will be now. 7 is assigned to num. 7 is assigned to num. Now, once again, num is reinitializing. What is the operation that is performed now? What is the current value of last digit? Current value of last digit, as you can see here, 80. 80 is the latest value of last digit. What is the value of num? 7 is 87. Now, the result will be 87. Why? Because num only keep on reinitialized. Num only keep on reinitializing. 87 we get. Initially, we get 78 and the reversed number 87. Simple logic. 78, 87, 78, 87. Simple logic. Understood or not? Please reply in the chat box. Understood or not? Am I audible? If I'm not audible, please let me know. Okay. If I'm not audible, please let me know. And whether you understood this program or not, please respond in the chat window. Very simple logic. These are the simplest. Yeah, sometimes your voice is slow. Now come to the next problem. Okay, fine. So observe, I got one query. What about 3 digit? Okay, it works only for 2 digit. Okay, for 3 digit, we'll see. For 3 digit or whatever the digit is there. Okay, not only 2, not only 3. Whatever the digit is there, we have a logic for that. That we will see. Okay, come to this program. Reversing any digit number using while loop. Not only 2 digit, not only 3, any digit. Okay, please grab a pen and paper. Okay, otherwise you don't get, otherwise you get confused. Please get one pen and paper. Try to analyze the code. Try to analyze the code. Observe carefully here. Iteration by iteration. Iteration by iteration, I'm performing the See, all these are steps, all these are iterations. See, I'll give some time, okay, not much. Please try to analyze. I want to reverse this number 3421. It should come 1243. It should come 1243. Okay. Now what you can do is keep like this. First iteration. Okay. Keep the variable num, reverse num, last digit. Okay. Keep on computing the results. At the end, you'll get the result. At the end, you will know the result. Please try it. Logic is there. The only thing you need to do is you need to analyze. You need to analyze how it is working. How this logic is working for the given number. I need to reverse this given number. Please try out. Please try. Okay. Observe carefully. This is the logic I have. This is the logic. To reverse any given number, to reverse the digits of any given number. Now I have three variables here. Int num, reverse num, last digit. Num is 3421. Reverse num is initializing with 0. Reverse num is initializing with 0. Then last digit. Last digit. It is just declared, not initialized. It is just declared and it is not initialized. And I'm just printing the base number, original number. Now while loop is there. Till num is not equal to 0. Till num not equal to 0. Okay. Till num not equal to 0, it will return true. It will return true. And you can able to execute the body. And you can able to execute the body. When num becomes 0, it returns false. So it will be coming out of this while loop and printing the value of reverse num. Printing the value of reverse number. For the first iteration, for the first iteration, what is the value of num? 3421 is the base value, original value. So obviously it is not equal to 0. Entering the while loop. Last digit is equal to num mod 10. Last digit is equal to num mod 10. So it is returning as the last digit. What is the last digit? 1 is the last digit. So last digit is stored with the value 1. What about reverse number? Reverse number. Reverse number is equal to reverse number. What is the current value of reverse number? That is 0. 0 into 10. 0. This whole expression becomes 0 plus last digit, that is 1. 0 plus 1, that is 1. Reverse num variable, it is stored with the value 1. At the end of the loop, what we are doing, num is equal to num divided by 10. Num is equal to num divided by 10. We know very well about this division operator. We are performing the division operator by 10. That is, it is removing the rightmost single digit, rightmost single digit. Rightmost single digit is removed. 1 is removed. And num is reinitialized with the value 342. Num is reinitialized with the value 342. Now, so these are the values for the first iteration. So now while loop will be performing the next iteration, second iteration. While loop will be performing the next iteration, second iteration. Number is not equal to 0, obviously. 342 is not equal to 0. Then entering the body, performing the operation. Last digit is equal to num mod 10. What is the current value of num? What is the current value of num? Current value of num, it is 342. 342 mod 10. It is returning as the rightmost single digit, that is 2, right? That is 2. Now reverse number, it is reinitialized. What is the current value of reverse num? Current value of reverse num. Current value of reverse num is 1. 1 into 10, 10. 1 into 10, 10. Plus the last digit, that is returned by the mod operator. Last digit, that is 2. 2. Then it becomes 12. Reverse number becomes 12. 10 plus 2 becomes 12. Reverse number is initialized with the value 12. Num equal to num divided by 10. Okay. So it is removing the rightmost single digit. Rightmost single digit. It is removing the rightmost single digit. Now 2 will be removed. Right. 2 will be removed. And 34 is the value. 24 is the latest new value of num. Num is reinitialized with the latest value 34. Come to the third iteration. Of course 34 is not equal to 0. That is why we can able to enter the while loop. Third iteration. So last digit, last digit equals to num mod 10. So what is the num value now? Current value of num 34. It is returning as the 4, right? It is returning as the 4 value. Last digit is 4. Last digit is 4. Then reverse num is equal to reverse num. What is the current value of reverse num? That is 12. 12 into 10. 120 plus last digit plus last digit. Last digit is 4. Now reverse number, it is initialized with 124. Then num equals to num divided by 10. It is removing the rightmost single digit. It is removing the rightmost single digit. What is the single digit we have? 3. That is removed. 3 is removed. 3 is removed. Then, so num becomes 0, right? Num becomes 0. See, not in this iteration actually. The thing here it is for the third iteration, the number is 3. Okay. Num value is 3. Now, if and only if num is having some digit, it can enter the while performing 4 iterations here. Performing 4 iterations. Performing 4 iterations. Now, what about this fourth iteration? Last digit. Last digit. Num value is 3. 3 mod 10. Returning 3. Returning 3. Then reverse number. Reverse number is equal to reverse number into 10. What is the current value of reverse num? 124. 124 into 10 plus 3. It is 1243. 1243. Right? 1243. Then the rightmost single value that is available is 3 only. Right? 3 only. So that is only removing. Num is equal to num divided by 10. Rightmost, the single digit, the only available digit is 3. That is also removing. Then num is becoming 0. Then num is becoming 0. Now what is the reverse number value? That is 1243. We got our results 1243. Original value is 3421 and the ending value, that is reverse number, that is 1243. Run as Java application. So are we getting the reversed order? 3421 1243. Guys, any confusion? Any confusion? Do I need to explain it once again? I can able to explain once again if you want. Understood or not? Please reply in the chat window, chat box. You just need to keep on, keep the values of variables. You need to make note of variable values. That's it. Anybody wants once again explanation? Please let me know in the chat window. Understood? Yeah, of course we can have 0 in the middle, but at not the end. Right? known as Java application. See, we can't have last digit as 0. In between it is fine. In between it is fine. 102043. If you are keeping 0 at the end, you'll get the different result. So, oh, we cannot expect the result. Okay, we cannot expect the result. Different result we are getting. We cannot expect if in case if I include the 0 at the end. Come to the next program. Uh, Before we need to cover one more thing. Yeah, finding out the number of digits available. Finding out the number of digits available in the given number. Okay, I want to find out how many digits are there in the given number. Please try to build a logic for this problem. Please try to build a logic for this problem. Don't refer to this logic. Please try to build your own logic. You can send it in the chat box. I want to find out the number of digits available in the given number. How many digits? I want to make a count of digits. How many digits are available in a given number? This is the simple logic to find out how many digits are available in the given number. The base value is the original value is 1 2 3 4 5 6. 1 to 6 we have 6 digits we have 6 digits we have. See, I need to make a count of this digit, so I'm keeping one variable with the name as count. Count is equal to 0. Count is equal to 0 if, sorry, while loop I'm using. While num not equal to 0. While num not equal to 0, then only you can enter the body of this while. After immediately executing this while body, it is incrementing. Count plus plus. Count value incremented by 1. Count value incremented by 1. Then num is reinitializing. Num is reinitializing. Num is equal to num divided by 10. Removing the rightmost single digit. Removing the rightmost single digit. Right. Removing the rightmost single digit. Every time till it is till the num becomes 0. Till the num becomes 0. In the first iteration 6 will be removed, second iteration 5, third iteration 4, Fourth iteration 3, fifth iteration 2, sixth iteration 1. Observe here. Count plus plus. After immediately entering the while body, it is incrementing 1. 0 is becoming 1. 0 becomes 1. Now, M is reinitializing. So, 1, 2, 3, 4, 5, 6 is there. Now, removing the rightmost single digit. Removing the rightmost single digit is removed. Now, value is 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5 not equal to 0. Entering the while body. Count plus plus. Count is becoming 2. Count is becoming 2. Now, num is reinitializing. Num divided by 10. Removing the rightmost single digit. Removed. 1, 2, 3, 4 is not equal to 0. Entering the while body. Count is becoming 3. Count is becoming 3. Now, removing the rightmost single digit. Removed 4. 1, 2, 3 is not equal to 0. Entering the while body. Count is becoming 4. Count is becoming 4. Num is reinitialized. Num is reinitialized with num divided by 10. Removing the rightmost single digit. 3 is removed. Okay. 12 is not equal to 0. 12 is not equal to 0. Entering the while body. Now count becomes 5. Count becomes 5. Now removing the rightmost digit 2. Removing the rightmost digit 2. So 1 is not equal to 0. Observe. 1 is not equal to 0. That is why we can able to enter the body. Count is becoming 6. Count is becoming 6. Now num is reinitialized. Num divided by 10. Num divided by 10. Removing the rightmost single digit. Only available digit is 1. Removing that, returning 0. Removing that and returning 0. Now whether 0 not equal to 0, what happens? It is becoming false. Why? Because it is 0 is equal to 0. 0 is equal to 0. The condition becomes false. Condition becomes false. Coming out of this while loop, printing the count. Count value it is now 6. Observe carefully. Simple logic. See, somebody asked here, um, why it is not, why it won't work when 0 is at first. Okay, sir. If 0 is present at the end, okay, what happens? After removing all the elements, 0 comes, right? 0 comes. See, while won't be executing, right? While will be becoming false. While loop becomes false, right? So it won't enter the body. It won't enter the body. And even we don't need like this, right? We don't want a number like this. Okay, we can remove this. Remaining digits are only matter. If I include the 0, this one matters. This one matters. Now run as Java application. 7 digits we have. Perfect. That is the reason you cannot have 0 in the beginning. If it is 0, it won't enter the while only, right? Won't enter the while only. And we don't need 0 in the beginning. Necessary. Now um, somebody's sent me a number. It is 36774046. 1 2 3 4 5 6 7 8. What is the problem here? Are we getting same? 8 digits we have. Am I correct? No issues with number. This number. 8 digit is returning, right? That is the problem statement. I need to return the number of digits are available. Now, for decimal number, this logic won't work. Okay, for decimal numbers, this logic won't work. See, observe. See, in case of in between zero, right? In case of in between zero, what happens if a number is like this, right? Um, I want to remove that number 67740. 0 should be removed, right? 0 should be removed. 0 is removing and 36774 is sorry, what is the value here? It is removing, not returning, right? It is removing. It is removing 0 and returning this value 36774. Still we have the number, right? See, of course, like it is 40, right? It is not like it is 0. if it is like this, last number will be removed. Last number will be removed, right? Last number will be removed. Then 0 comes. Anyway, we cannot able to enter the body with 0. If it is like this, then it is fine because still number is there. After removing 0, 2. After removing 0, we get to 2. We can able to enter the while body 2. So if it is like this, 2 not 4, removing the last digit, that is 4. Still we have 20, not 0, right? Not 0. If I remove 4, we get 20, right? Then we can able to enter the while body. It is not like 0 2. Understood or not? Understood or not? Guys, any number, okay? Any number, any number. So observe here, this comes out of int, okay? Out of int range. Try to give it wrong. Guys, here I need to give wrong. Run as Java application. So what we are getting here, 10 digits. Do we have 10 digits? We have 10 digits, but the only thing you need to increase, okay? Int cannot hold this many values. Int cannot hold, int data type cannot hold these many values. So that is why I have used long. Okay, it is larger data type than int. It is having the larger space than int. Got it or not? See, if I take int, okay, what happens if I take int? If I take int, see this int range, okay, this int range cannot hold these many values. Remove the L. This value cannot be held by this int range. That is the problem here. We can go for long, right? That is why we have long data type to represent these many numbers. So if it is like this, we cannot able to run itself. Why? Because compile time error is there, right? Compilation error. We cannot able to run without compilation success. Without compilation success, we cannot able to run. We cannot able to see the output. Now that is why we can use the long, right? Long. And long can hold this many numbers. Only thing you need to follow is keep L at the end so that this number will be considered as long number. Now we get the result as 10. We have 10 digits here. Any doubt? Any doubt in this program? Any doubt in this program? Come to the next problem. To find out sum of all digits in a given number. To find out sum of all digits in a given number. Find out the sum of all digits in a given number. It can be any length. It can be of any length. That is in the int range. That is in the int range. Sum of all the digits in a given number. Simple logic. Base number, original number is 123. 123. Sum is equal to 0. Initializing sum with 0. Initializing sum with 0. Now, while num not equal to 0, of course, as of now, num is not equal to 0. It is 123. Entering the while body. Sum is equal to sum plus num mod 10. Sum value now, as of now, it is 0. 0 plus num mod 10. Returning the rightmost single digit, that is 3. First iteration, how it is. Observe. Sum is equal to sum plus 0 plus sum mod 10. Returning the rightmost digit, that is 3. So, is the value for sum now, as of now. Now, num is reinitializing. Num is replacing with num division operator 10. Removing the rightmost digit. Removing the rightmost digit. 1, 2. It will be gone now. It will be gone. Now, of course, 1, 2 is not equal to 0. Sum is equal to sum plus num mod 10. What is the current value of sum? 3 plus num mod 10. What is the current value of num? Current value of num, it is 12. Returning us the rightmost value, that is 2, is equal to 3 plus 2 is 5. 3 plus 2 is 5. Removing the rightmost single digit. 2 is removed. 1 is the value. Now come to the third iteration. Third iteration. Sum and sum. Sum is equal to sum is the current value of sum, 5. Sum plus returning the rightmost digit of the current num, That is 1 becoming what? 6. Removing the rightmost single value, that is 1. 1 is removed, so 0, 0. Now, of course, we cannot able to enter the while loop with 0. It is returning us false. 0 is not not equal to 0. That means it is returning us the false. When this expression becomes false, we cannot able to enter the while body. What is the sum now? What is the sum? That is 6. 6 will be returned. 1 plus 2 is 3. 3 plus 3 is 6. Right click, run as Java application. 6 is the value we are getting. 6 is the value we are getting. And you can try it for any of the digit. What is the sum now? 10 is the sum for 1, 2, 3, 4. Guys, please don't leave the session. Okay. At the end, actually, I'll be sending now the link to register your attendance, to mark your attendance. Please mark your attendance. I've given you the link. Please mark the attendance first. It would take you 10 seconds. Please mark the attendance and please don't leave. Please don't leave. Still, we have 25 minutes, 24 minutes we have still. Please don't leave the meeting. Guys, come to the next problem. Observe this program. To find out the multiples of a number in between two given numbers. To find out the multiples of a number in between two given numbers. I want to find out the multiples of the number, whatever the beginning number is there and whatever the ending number is there. In between that, I need to find out the particular, see the multiples I'm going to find out. Multiples of a number in between two numbers. Multiple multiples of a number in between two numbers. Multiples of a number in between two numbers. Now, int num1 is equal to 31. Int num1 is equal to 31 and int num2 is equal to 65. This is the beginning, okay, and it is the ending. From 31 to 65, I need to find out the divisors. I need to find out what are all the numbers can be able to divided by 5. What are all the numbers or can be able to divide by 5 with the remainder 0. With the remainder 0. From 31 to 65. I'm using for loop. Int I is equal to num1. Int I is equal to num1. That is 31. 31. I less than or equal to num2. That is 65. Here num2 is 65. I plus plus. It is the initialization part. Int I is equal to num1. Int I is equal to num1. It is the initialization part and it will be only executing only once. It will be executing only once. We have three parts. One is initialization part, then checking the boolean condition part, then we have the increment or decrement part. First section executes only once at the beginning. Now 31, whether 31 is the 31 can be able to divide by 5. 5 can be able to divide the 35, sorry, 31. 5 can be able to divide the 31. 31 mod 5. 31 divided by 5. Is that possible? No. What is the next divisible of 5. 35. 35 is the next divisible by 5. Like that till 65. Like that we need to find out till 65. See why, how it is this for loop is working. Basically I is initialized with 31. Now 31 less than or equal to 65, of course. So till I becomes, till, what is the value here, I is incremented, right? I is incremented till I becomes 66. Till I becomes 66, it will be keep on iterating. You can able to find out the I value here. Observe here, int I. Instead of declaring inside the for loop itself, I'm declaring it outside the for loop. Now what is the use of this? If I declare the for loop, sorry, if I declare the int value within the for loop, I can only use within the for loop context. I can only use within the for loop context. Okay, this is the for loop context. This is the for loop area. And I cannot use this int I outside the for loop. If I'm declaring int I here, if I'm declaring int I like this, I cannot able to, not able to use this I outside the for loop context. Okay. Outside the for loop context, you will get the error here. I is not visible. I cannot resolve to a variable. I is not visible here. Okay, I is only for loop. So that is why I need to find out the I value, right? That is why declaring it in the beginning itself for loop. Then I'm printing the I. Now after printing all the divisibles, after printing all the divisibles from 31 to 65, after printing all the divisibles from 31 to 65, I get the value of I, right? What made the for loop break? What caused the for loop to break? I need to find out that value, right? That is the thing I'm trying to find out here. Right click, run as Java application. Observe after 65, after 65, we are getting the 66. All these are can be able to divide by 5. These are the divisibles of 5. Divisibles of 5. These many numbers are there in between 31 and 65. And when I becomes 66, when I becomes 66, 66 is not less than or equal to num2, right? 66 is not less than or equal to 65. So it is causing the loop to break. It is returning the false. So control will be coming out of this for loop and I can able to print the I value, that is 66. 66. Not only divisibles of 5, I can able to find out divisibles of 2 as well. Any number, any number. These many numbers we have from 31 to 65. After this, we are printing the I value that is caused the loop to break. That is 66. That is 66. See here, observe carefully. Less than or equal to I'm giving, not less than. Less than or equal to. Less than or equal to. It is considering now 65 as well. Sorry. Now it is not considering 65. Okay. Now it is not considering 65 here. That means whether 65 is less than 65. No, right? Whether 65 is less than 65. No. Those are equal. Now we'll get here 65. This is the end value that is caused the loop to break. Now I want to find out till 65. I want to include 65 as well. Okay, I want to include 65 as well. So that is why I'm giving the is equal to including the 65. Then whenever I become 66, then only whenever I becomes 66, then only loop will be becoming false. This loop will break, returning false, coming out of the loop and printing what caused the loop to break. Got it? Now observe what what happens in this case. What happens in this case? See, in the previous case, it was 31 and 65. It was 31 and 65. Okay. The beginning number is smaller and the ending number is bigger. But in this case, reverse. It is beginning number is bigger, ending number is smaller, right? Beginning number is bigger, ending number is smaller. That is num1 is the beginning number, that is 98. Num2 is the ending number, that is 21. That is the ending number. Okay. In this case, I want to decrease the I value by 1. I want to decrease the I value by 1, right? I want to decrease the I value by 1. That is the case here. I is equal to num1. I is equal to num1, 98. 98, it is greater than or equal to 21, of course. But I cannot say like this. Will become false for the first iteration itself, because 98 is not less than 21, not less than or equal to 21. That is why I'm giving greater than. Then after that, I minus minus. After the iteration completes, okay, after this body executes, I will be becoming, I will be decreasing by 1. I will decrease by 1. Now what will be causing the loop to break? What will be causing the loop to break? That is the value I'm printing. So it means I becomes 20. I becomes 20, right? So in between 98 and 21, in between whatever the numbers are, can able to divide with 7. Okay, those numbers are printed. Okay, in the like from 98 to 21, it is in the decreasing order. That will be printed. Then after that, what is the I value that is caused to break the for loop? That value will be printed. What is that value? 21. These are all the numbers from 98 to 21, 98 to 21, right? Then when I becomes 20, when I becomes 20, then when I becomes 20, loop is breaking, right? It becomes false. So it comes out of the loop. Then I'm printing the value 20. Got it or not? You can try with any divisor. You can try with any divisor. That means the multiples, multiples of a given number. So guys, for today, this is it. Okay. Now from tomorrow, we'll finish some of the remaining number system programs problems. Then we can able to move to the arrays concept. It is very important, arrays concept. Okay. So thanks everyone. Good night.